Hello students, Mr. Greg here. I hope you are doing well, and I hope you were able to get Python downloaded on your computer. I apologize to you that we're having a few issues. I think we've got those corrected by now, but if not, don't worry, don't panic. We'll get that done and we'll get you caught up this week. So one of the reasons I gave us a week just to get Python loaded was in case there were any issues, we could get those resolved. So I think everyone has theirs downloaded now and they're not getting those error messages. And so I want to get us started in programming in Python. So the first thing we're going to do is we're going to go down to our command bar, and we're going to type in idle. Let's try this again. IDLE, and then you should see a selection pop up that looks like this. Go ahead and click on it, and this is going to open up the Python shell. Now you remember we could do commands in the shell and they would work fine, but it's really not the best way to work on Python, to do Python programming. A better way is to actually open up a new file and do our programming inside the new file. And so that's what we're going to learn today, is to write a brief program, and all this is leading up to more and more interesting things that we can do through Python. So I'm going to come over here. I'm going to click on File. I'm going to click on New File, and that's going to open up a nice new window for us. All right. So Python has a lot of capabilities, but one of the neat things about it is that there's a whole world of graphic interfaces that we can learn to do. And if you remember in the last lesson, I kind of showed you what the goal was, at least for now, to get us started. And so I want to help you learn how to do the measurement and how to make the graphic bar move back and forth in real time, exactly with the measurement that we make on our sonic sensor. All right, and so to do that, the first thing we're going to need to do is import a library. Just like with Arduino, you have libraries in Python, and so I want to import serial library. You see it turned the nice colors. Now, one thing in Arduino, you remember you use the backslash to put our notes in, right? In Python, you don't use the backslash, you use the hashtag, or what we used to call the number sign. So this is how you put notes in, and I want you to put your comments in here like we did for the Arduinos, because as you get more and more complicated programs, we're going to need to be able to read those and understand how your program works. All right, so we're going to do import serial, which imports the serial library, and then we're going to bring in another library. We're going to call it, it's the visual library. So we're going to type in from visual import, and we're going to give it a special character, and that's this character, the asterisk character, which is shift 8. So it should turn colors, as you can see on my screen. I hope you can see that well. From visual import. In fact, I'm going to make this larger, and maybe that will help. Actually, I got something else I'm going to do. All right, I made the font a little bit larger. Didn't torture you by showing you how I did that, because I don't think it's going to be necessary for you. So again, I've typed in import serial, And then I loaded a new library we call Visual, and we import it this way. So nice thing about the Python is that you don't have to necessarily end all the sentences in a semicolon like you do Arduino. You just type it in and it goes. And so it just understands exactly what you're doing. All right, so we are going to be reading data from the Arduino. And so Python is going to reach out, get data from the Arduino, download it in Python, reorganize it, and put it in a packet that is useful for Python. And so we have to tell Python to communicate with the Arduino, and we have to tell it what COM we're communicating to and at what speed. And so I'm going to show you how to do that now. So you need to make sure your Arduino is hooked up. Make sure your sonic sensor is running and that you're getting information on the serial port on Arduino. And then we can do this next step. So what I'm going to do is I'm going to minimize this for now. I'm going to switch over to our Arduino, and here's the sonic sensor code. I'm sure it looks familiar to you. And I want to make a change for you, and that actually we're going to use a faster speed than the 9600 rate. So you probably have 9600 here in your serial begin, and I want you to change that to 115200, 115200. It just when you're moving back and forth like that and you're doing some pretty serious graphics, you want to use a higher speed, and so that's what we're doing. So make that change, and then I need you to go up to Tools. All right, and you should have Arduino Uno checked, and then you should say, it should say a COM. Now mine says COM 11, yours most likely is going to say something else, but I need you to look at that, and I need you to write that down. So I want you to write the speed down, and I want you to write what COM you're on down. All right, because we're going to need that here. So like I said, we're going to be talking, and we're going to be talking at a pretty fast rate. And so let's just think about this. So we got to set up a bucket, right? Like we always do, right? So we're going to call that bucket, I'm just going to call it Arduino serial, capital S, capital D, data, right? And that's going to hold that information that we get from the Arduino. And so we need to read that from the serial port. And now's a good time to tell you, when you're in Python and you're using the serial port here, then you can't use the serial port on Arduino. Arduino can't service both of them. And so it's one or the other. All right, so Arduino serial data is equal to serial dot capital S, serial, open parentheses, apostrophe, COM 11. Again, yours may be something different. Oop. So apostrophe, COM 11, apostrophe, comma, 115200. I should have wrote that down. Just like that. Nothing at the end. Right? So COM 11, And I'll give you a chance to go back and look at it. COM11 here, double check it. Rate 115200. All right, now we're moving along. Okay, so if we're going to have a graphic that moves with our ultrasonic data, then we need to produce or create this graphic. And we need to call it something, so I'm just going to call it the measuring rod. Measuring rod. And there's a lot of shapes that are pre-programmed in Python. You can do circle, you can do square, you can do rectangles, triangles, all right? But I chose the cylinder. And so we'll type a cylinder in there. Now you got to give this cylinder a radius. So you've got to think about, as you're creating a virtual world, about the dimensions in that world. Okay? And Python doesn't really care about the dimensions, only that they're relative to each other. So I can put a number in here, 4,000, right? And it can mean 4,000 millimeters, 4,000 inches. It just means 4,000, right? In our case, because we're measuring in inches from our previous program, that's the way we want to think of. If you take my SolidWorks class, one of the first things I try to help the students understand is you have to get this spatial recognition of a 3D object on a 2D plane. And when I talk to employers who hire students or college graduates to do programming and design, they say that's one of the hardest things that they have to overcome, is getting used to that spatial recognition. So if you start now, you'll be ahead of the game. All right, so we have a cylinder. The cylinder has to have a radius, right? And since we're thinking in inches, I'm going to do 1/2 inch radius. Again, that could be 1/2 mile as far as Python is concerned, but everything has to be relative, right? I wouldn't want a radius of my cylinder to be 1/2 mile and I measure in inches. That wouldn't make sense. All right, well, it needs to have a length. Right now, we're just going to give it a length to make sure everything's in there, length. And I'm going to give it a length of 6 inches. And then we can give it a color. There's not a lot of colors in Python unless you do some special programming, but there's your basic ones. I think yellow and blue and red and I don't know. Anyway, I know yellow's in there, so we're going to do yellow, color dot yellow. Oop, that's wrong. It's color dot color. Nope, that's wrong too. It's color equals color dot yellow. Just keeping you on your toes. All right, so we've got a radius, we've got a length. So this is actually sets up our measuring rod. All right, so now, if you remember in Arduino, we had the void set up, and then we had the void loop, and you had to set the variables up and all of those things. With Python, you don't have to do that, but if you want a loop, then you've got to make your own loop, right? And one way to make a loop is to use a while statement. So, for example, you can say while 1 is equal to 1, and you actually do use a colon on this on your while loop. So when is 1 equal to 1? All the time, right? So while 1 is equal to 1, equal to 1, then it's going to run through this loop. And since 1 is always equal to 1, then it'll continue through this loop. Another way of doing this, I can find my cursor, is to say true. T-R-U-E. Can't remember if that's capitalized or not. Let's see here. Yes, it is capitalized. Sometimes I get these programs all mixed up. While true, right? When is true? True. True is always true, despite what liberals would tell you. While true, then it'll continue through these loops. So one thing that's very important in Python, it's a good thing to mention here, is the spacing. You notice when you hit the enter, it automatically indents. Well, it needs to maintain that spacing for the while loop to work correctly. So we got while true, all right? True is always true. And then we want to say an if Arduino serial data, while it's reading, which we use a code in capital W-A-I-T-I-N-G, open close parentheses, while in waiting, is greater than 0, right? That means while there's data, then we want to grab that data. All right, I'm going to click a tab, hit my tab button, indent over one time. And we want to put that data in this bucket, which we call Arduino, we call it my data, Arduino serial data dot read line, like that. All right, this needs to be a colon. I already see a mistake. All right, so Arduino's, so Python's sitting there, we're trying to get data. If there's no data from the Arduino, then we have 0, nothing happens, right? If it's greater than 0, which it should always be, then we're going to read that data, read line, and we're going to put it in a bucket called my data. And then what do we want to do? We want to print my data. So let's see if this will run. So the way you run a program in Python is you go up to run, up here. See this? Hopefully you can. Click on Run Module. And it should, oh, you got to save it. Really. Python class. Save. Uh-oh, we have an error. Oh, I forgot to put the parentheses around my data. Let's see if that's right. Run module, okay. Oh, really? All right, let me look at this and see what I've done. Okay, I see what I have done. I am actually using my knowledge from a couple of years ago of Python. This visual import is actually changed and it is no longer used. Instead, you write vPython import in here. Let's see if this will work. Run module. Okay. What's happening? Could it work? Getting a new window? All right, well, there's our rod. It's not really much to look at, but it is progress. And here is our data. We're getting a B something 3.42. So I'm getting some information here. I'm going to see if I can turn this to the webcam. Oh, there we go. So there is my sonic sensor. There is my target. Now you can't see the data. I really need. There, oh boy, that's terrible. Well, I hope you can see that. So you can see the data is changing. So I'm going to take that away and get a big number. There we go. 12. That's about right. Put it back. All right. So we are getting some data slowly. But we also got this annoying RN stuff, which I'm not really sure I understand why it does that. But we're going to see if we can't get rid of that by going here. Okay, so I'm going to exit out of this. Exit out of here. Go back to our code. And then I'm going to get you to type something in that will get rid of those lines. And we need to do that before our print data, obviously. All right, so I was just taught to do this, and I'm just teaching you to do it. I don't understand it. But, well, I understand a little bit. So we want to take our data. It's coming in as a string, str, right? Data. And then Python uses a type of data, they call it UTF-8. And that's, you're getting part of that information. When we are downloading our information to the serial port. So anyway, all right, so you want to put in here data is equal, it's a string, right? Data, and then this apostrophe UTF-8 apostrophe, and then in parentheses, like that. It seems to like it. So let's run it again, run module. Okay. Starting back up, opening the graphics window. There it is. Oh, it didn't like it. I spelled something wrong, there's no doubt. See, this is good, because you probably think I don't make errors. Let's get that out. It's probably not Let's see here. Oh, should be my data. Print my data. All right. Have to get it right. My data, run module. Okay. And it's there. Did something wrong. I see what I did. My data. Now let's try it. Everybody say a prayer. Prayers are welcome. Yes! Woo! See if we can get it to change. A little bit slow. I know how to fix that. Move this. Yeah. All right. Kind of slow to react, so let's fix that. See if we can fix it. I'm going to exit out. This will be the last thing we learn today because I don't want to make these videos too long. So when you're reading data like that over the serial port, you need to give it a rate. And so we are going to give it a rate. This is something that can vary depending on the sensor and everything else. But since I've been dealing with this sonic sensor for a little while, I felt like a rate of 20 worked pretty well. So let's see if that helps it any. All right. Let's see if that helps it. Yeah. Yeah. See? Helps my rate a little bit. Not as much as I'd like. But we are getting data. All right. So that is good for this lesson, number 7. This is your homework to get to this point. Write out the code, get through all the bugs like I did, and let me know that you were able to make this yellow cylinder. And then next week we will work on getting it to adjust based on the data distance that we are gathering from Arduino. So as usual, call me if you need me. Have a great day.